questions after the class, feel free to stop by my office or email me. Okay? Then let's continue our discussion on the chapter 9 and 11. So last week we mainly talked about sampling distribution. We talked about sampling distribution for the sample proportion, and we also talked about the sampling distribution for sample mean. Okay. Those are the two concepts we discussed. And the underlying theory behind that sampling distribution is the central limit theory. Okay. We will also discuss the central limit theory in the last class. So today we are going to start a new concept. Okay. So if we see this slide, so when we talk about the sampling distribution, we assume that we know the population parameter. So for example, I know the proportion of management students in this class. I know if the whole class is my population, so I know that information. But when I draw the sample, if I draw the sample here, I can use the population parameter to estimate what is the distribution of the sample proportion I will get. Okay? So that is from the population parameter, using this population parameter to estimate what my sample statistic would look like. Right? So this is this way around, this direction, population parameter to sample statistic. The next concept we are going to discuss is the opposite. So we want to study this confidence interval. Right? So we will discuss what is the concept of the confidence interval. But the logic is that we do not know the population parameter. Okay? We do not know that. But what we want to know is the sample statistic. For example, assuming I do not know the average GPA of this class, but I want to use my sample to study that population parameter. So that is the confidence interval. That's the second way. We use the sample statistic in hope of learning the population parameter. Okay. Just like the survey before the presidential selection. So different agencies did a lot of surveys, just collected a lot of samples. The purpose is to use the sample statistic to estimate what is the proportion of US population support Donald Trump, and what is the proportion of US population support Hillary Clinton. Okay? So because they want to use the sample, they cannot access the whole population. So that's why the only thing they can do is to collect samples and calculate the sample statistic, and use this sample statistic try to estimate this population parameter. So the problem is, so if we want to use the sample statistic to estimate the population parameter, so is that possible to have an accurate or exact population parameter? So if I say I collect a sample in this class about the proportion of management students in this class. Okay? So the proportion I get is, for example, 25%. Okay? Among this sample, 25% of those students are management major. And I want to use this number to estimate what is the proportion of management students in the whole class. So can I get an accurate or exact number for that population parameter? The answer is no. Okay. We can, if we collect a small sample like this, we can never get an exact number for this population parameter, unless you collect the entire population as your sample. Right? In that way, you learn the entire population, you will get the exact population parameter. But if you select a small part of your population as your sample, it's impossible to use this sample statistic to have an actual number for this population parameters. So that's why we want to learn this confidence interval. Okay? So what is the interval? That is the interval that contains the true population parameter. Although we cannot find an exact number for the population parameter, but we want to do our best. So when we do our best, so that means we want to have an interval. We have a certain level of confidence that this constructed interval will have the true population parameter. Okay? That's the best we can do. We cannot pinpoint that true population parameter, but we can have an interval. We know we can say that with a certain level of confidence, the true population parameter is somewhere in this interval. Okay? So that's the concept of the confidence interval. Okay? So in this slide, we want to know what's the difference between the sampling distribution and confidence interval. Okay? So this will tell us what is the difference. Okay? So any questions on this slide? Then let's talk about the confidence interval. Okay? So in order to construct a confidence interval, we have several elements to learn. So the first element we want to learn in order to construct this confidence interval is the standard error. Okay? So what is the standard error? So here, if you see this title, the confidence interval for proportion. Again, for the confidence interval, we also have two applications. One is the proportion, the other is the mean. So similar to the sampling distribution. For the sampling distribution, we learned the proportion and we learned the mean. And for confidence interval, we also first learn the proportion. So we want to estimate what is the population proportion. Okay? So that's why we want to first learn the first concept, the standard error. So in this case, we do not know anything about the population. Okay? We have no information about the population. But what we have is our sample. We have our sample. So that's what, then we want to find out what is the information we can get from the sample in order to estimate the population. Right. And then we want to estimate what is the distribution of the population. So in the previous, when we discussed the sampling distribution, we learned the standard deviation of the sample statistic. And we use the population parameter to estimate the distribution of the sample statistic. But here, because we only have the information about the sample, so that's why here in order to estimate the standard deviation of the population parameter, we use our sample statistic information. So this standard error is equal to square root of the p hat times q hat over n. So this p hat, if you remember, when we have a hat in the above the p or the q, that means that is the sample. That's the sample information. Okay? That is the sample proportion, the p. Okay? It's not from the population. If we talk about the population, there's no hat. When we have the hat, that means this proportion is from the sample. Okay? So it's p hat times q hat. Q hat is equal to 1 minus q hat. Okay? So the format is similar to the standard deviation of the sample statistic. But the difference is that here we use the population, we use the sample proportion. Okay? So how do we do this calculation? Here's one example. Okay? Assuming we have a sample and we did our calculation and we find out, okay, the sample proportion is 0.42. Okay? And we have 35, 59 samples. That's our sample size. And if we plug the numbers in there, so we will have the standard error. So standard error is one of the components when we construct the confidence interval. Okay? So what I need you to remember is this formula, how to calculate the standard error of the sample proportion. So this is the formula I want you to remember. So any questions on this slide?
What is the one come?
One, okay. So this point 42, that is p hat, right? This point 42, that is the p hat. And 1 minus point 42 is the q. We know q is equal to 1 minus p, right? So that is what? This is the p hat, 1 minus p hat, which is equal to q. Any other questions?
With the n, maybe?
This value? We'll work on this type of problem. You will know the n, because that's only sample is the only information we know. Okay? We know everything about the sample. Okay? You will be given this number. Any other questions? So how do we use this standard error? We know this standard error is the kind of standard deviation. Okay? So if we look at this figure, we know this is our population parameter, but we don't know this. So we only use P here to denote the population parameter. And we just calculated the standard error, which is a type of standard deviation. So if we use this rule, 68, 95, and 99.7 rule, we add one standard deviation for the true population parameter and two standard deviations, three standard deviations. So this is the figure we will use. We know that 68% of the sample of that size. So what is the sample size? This is our sample size. 68% of that sample will fall into this area, this interval. Okay? So that's the definition of this rule, right? And if we look at two standard deviations away from the true population parameter, although we still don't know where this is located, but we know 95% of that kind of sample will fall into this area. Okay. So that's where we put our standard error. Still, how do we use this logic to estimate where this population parameter is located? So that's why we want to construct this constant interval. We know that the population parameter, in this case, we are talking about the population proportion, is located somewhere. And if we use the standard deviation, we know that 68% of the sample will be within one standard deviation away from the true population parameter. So that is we are looking at the whole thing from the perspective of the true population parameter. Okay? If I'm the true population parameter, the sample, 68% of the sample will fall into the area of one standard deviation away from me. Okay? Probably here or there, but it's one standard deviation from me. Okay? That's from my perspective. Okay? That is from the true population parameters perspective. But if we look at the whole thing from the perspective of the sample statistic, okay? The true population parameter is here, and I'm the sample statistic. I know that there are 68% chance I will be within one standard deviation away from the true mean. The true population parameter. Okay? Although I don't know where the true population proportion or the true population parameter is located, but I know that within this interval, I have 68% chance fall into this interval. And if I'm in that interval, that means the true population parameter is only one standard deviation away from. Okay? So that's how we construct this confidence interval. For example, this is the true population parameter, true proportion. So if we have the sample statistic here, so this one will be this true population parameter is 1 standard deviation away from this sample. And if we construct a confidence interval using the 1 standard deviation here, so we will have this one. So this sample, this population parameter will be in that region. So in order to utilize this confidence interval, we only have one assumption. And in order to meet this assumption, we have two conditions. Your sample should be a random sample. Okay? So that is one requirement. The other requirement is that 10% condition. So you cannot draw 50% of your whole population as your sample. So it cannot be over 10%. Right? So two conditions we have to meet in order to calculate the confidence interval. So we had similar conditions for the sample distribution. Okay? If you talk about the 10% condition, that's the same concept. So next element we want to calculate in order to construct the confidence interval is the margin of error. So the margin of error tells us how many standard errors or how many standard deviations away from the estimate or the sample statistic. Okay? The margin of error is equal to a critical value. So this Z star is a critical value. So I will talk about this Z star in the next slide. Okay? Let's just for now, let's remember this is our critical value. Critical value times, we just learned this one, standard error, right? So the margin of error is equal to the critical value times the standard error. And here, this is the general format for the confidence interval. So it's estimate plus and minus the margin of error. So we already discussed the confidence interval, that's the interval that we constructed. Okay? So how do we construct this confidence interval? Firstly, we need to have this estimate. What is estimate? This estimate is our sample statistic. This estimate is our sample statistic. So for this case, so because we are talking about the population proportion, so our sample statistic for this application is our sample proportion, the p-hat. Okay? So this is our estimate. This is our sample statistic, the p-hat, sample proportion. For example, here, this is our sample statistic. This is our estimate in here. So in order to construct a confidence interval, we need to have an interval, a range. So from here, so this extent, that is the p-hat plus the margin of error. So means this one is p-hat plus margin of error. This is one boundary, and the other boundary is p-hat minus the margin of error. So the center is our estimate or our sample statistic. from here we want to construct an interval. The upper bound of the interval is the p hat plus this margin of error. And the lower bound is the p hat minus the margin of error. And this is our confidence interval. This is how we construct our confidence interval. And this is one example. Okay? P hat is our sample statistic, is our estimate. And the margin of error. So in this case, the critical value z is equal to 2. Okay? 2 standard errors away from the sample statistic or the estimate. So this formula you need to remember, and this formula, this formula you also need to remember. So now we know what does that mean by saying margin of error, but we don't know the critical value. So what is the critical value? So the critical value is the number of standard errors or standard deviations away from the estimate. So we use the Z star to denote this critical value. So how to find the Z here? We know that we need to have some confidence about this confidence interval. So it's not going to be 100% sure the true population parameter will fall into this interval. So if we want to construct a 90% confidence interval, the corresponding critical value will define 90% of the area. And we know that if we look at this Z, when we talk about normal distribution, we know Z is a standard normal random variable. So Z follows a standard normal distribution with a mean of 0 and standard deviation of 4. So if we want to construct a 90% confidence interval, we have to find the Z value that define this region. And we know that this is a standard normal curve. And if this is 90% of the area, we can do the calculation to find this value. So let me show you how to find this Z star, how to find this critical value. So let me use this, so we can always use the stack branch because we are, here we are talking about standard normal distribution. Still you have to go to the stat, calculator, and normal. Again, if you notice, in the second exam, we used the stack branch a lot. Okay? Chapter 6, chapter 7. And in the following chapter, chapter 9, 10, 11, 12, we need to use the stack branch a lot. Okay? If we choose this between, we don't have to change the parameter because we know this Z follows a standard normal distribution. Mean is 0 and standard deviation is 1. And what we need is to put, for example, I want to find the 90%. I put 0.9 there. And this value is our critical value. This value is our critical value. So this is 90%. So what if I want to have 2 standard deviations? Because I know 2 standard deviations cover 95% of the area. This is 95%. Okay. I want to find this is our Z star. I want to find this value. And again, this is standard normal distribution. So how to find this one? So still, let's use the stack box. We know 2 standard deviations cover 95% of area. So what I will do is to put 95 there, and that will give us our critical value is 1.96. So that's how we find the critical value, the Z star. Again, this Z star, all our discussion is for the proportion. Okay? So we will talk about the mean after finishing this proportion. Okay? So here, when we talk about critical value, this critical value is for the proportion. Okay? So any questions about how to find the critical value? So in your homework, one possibility is that the question will provide you with the critical value. Okay? So if you work on a question, a problem, so it may give you a table, and that contains the critical value. But if the question does not give you the critical value, this is using this stack function. That's how you'll find the critical value. Okay? So some questions may ask you to construct a 95% confidence interval or 98%. That's the number you need to use. Use this number to find this critical value in the stack function. Okay? So any questions? So let's work on one question. So this is question number 1 in your homework. Okay? Question number 1. So the question is: an insurance company checks police records in 598 accidents, and notice that teenagers were at the wheel in 99 of them. So that's the information provided to us. And we need to construct a 95% confidence interval for the percentage of all car accidents that involve teenager drivers. So that's a question we may have. So there are several information we can have from this description. Our sample size, we are talking about our sample, right? Our sample size is 598. This is our sample size. We know that the confidence interval is this is our estimate, right? Estimate plus minus the margin of error. And this p hat is the sample proportion. What is the event we are interested in? We are interested in the number of accidents that involved teenager drivers. And it says 99 out of 598 accidents involved teenagers. So this proportion, this percentage is equal to 99 over 598. So this is our sample statistic. This is our estimate. And we know that this margin of error is equal to the critical value times the standard error. And this standard error is, let me write, p hat times q hat over n. So those are the numbers we have to know or calculate in order to construct this confidence interval. Okay? So this is our goal. This one we already did the calculation. That's our sample proportion or sample statistic. This one q hat. We know q hat is equal to 1 minus p hat, right? So when we do the calculation, we can also have the q hat, and we already know. The only problem is the z star. It has 95% confidence interval. 95%. So that means if you look at this figure, that means this area is 95%. I want to calculate this value. And we just demonstrated how to find this critical value using this number. So you see this is how we utilize this 95%. You use this 95%, then you can find this critical value. Then you plug the numbers in there. After we have the Z star, the critical value, we can do the calculation. But still, this is really time consuming. And I'd like to use the stat box to do the calculation for me. And this is the underlying logic for do the calculation. But in the homework, in the exam, let's use the stack function. The stack function has the function to calculate the confidence interval. Okay? So because right now we are talking about the confidence interval for the population proportion. Okay? So if you go to this stat, and this function called proportion stat. Let's remember this function. Stat proportion stat. And for now, let's choose one sample. Okay? One sample, then let's select this with summary. Okay? Let me do it again. Stat proportion stat. One sample. That's proportion stats, one sample with summary. If I click this one, this is the interface we will get. So here we have some inputs. The first one is number of successes. So the success, we already discussed that. Success is the event we are interested in. So here, we are interested in the number of car accidents that involved teenagers. So here we said 99 of the accidents involved teenagers. So this is our number of successes. This is our number of successes. And number of observations. That's our sample size. That is our sample size. In this case, 598. That is our sample size. The next thing we need to do is to select this confidence interval. You can just select this confidence interval. You don't have to worry about the method. We just use the default method. Another thing you may need to redefine is the confidence level. Here we just happen to have 95%, but sometimes you may need to calculate 90%, 98%, and so forth. So if you want to calculate 98%, you need to change this number. But here we keep the 95%. Three numbers we need to put in there: number of successes or the number of events that we are interested in, our sample size, and our confidence level. Okay. So this is the output window you will get. You have the sample proportion, which is our p-hat. Standard error, which is this one. And lower limit and upper limit. So if we have the interval, we will have, this is the lower limit, this is upper limit. And the question is asking the lower limit and upper limit. So if I put it there, so this, the lower limit is 13 point, how many decimal? 1 decimal. 13.6%. And the upper limit is 19.5%. So this is how we calculate the confidence interval. So when you have a question like this, construct 95% or 90%, whatever percent confidence interval, let's use the confidence interval function in the second. Remember, we need to select the proportions steps. Okay? We have other functions, but we will discuss those functions later. Right? That's not, if we know that we are talking about the population proportion. So, yes?
Is it always like a question that would always ask for the
So we will have more questions. So we will have different type of questions, but for most of questions we can use the stack function. So I will show some other questions as well.
Can you tell me how you use
So look. So here it's asking the confidence interval, right? So in order to construct the interval, you need to have a lower limit and upper limit. So if someone asks you the confidence interval, that means it's asking you the upper limit and lower limit. Okay? It's always like this to construct confidence interval. Because those are the two limits define an interval. And in some other questions, we may need to just calculate the margin of error or the standard error and so forth. But I will show you some other questions as well. Any other questions? So question part B, explain what your interval means. So that is related with the definition of the confidence interval. When we describe the confidence interval, there's only one way to describe it. That is, we are a certain level of confidence that the constructed interval capture the true population proportion or the true population proportion, or later on we will talk about the mean and other parameters. Okay? So that's the only way to describe that. So if we look at the three options, the first one, we are 95% confident that a randomly selected sample, randomly sampled accident would involve teenager or percent for interval. Okay. And second one, we are 95% confident the percent of accidents involving teenager is 16.6%. We don't even have this number. The third one, we are 95% confident that the true percentage of accidents involving teenagers falls inside the confidence interval limits. So this is how we explain the confidence interval. There are several key information you need to mention. The first key element is your confidence level. 95%. You have to mention that. 95% confident. So here. So if you construct a 90% confidence interval or 98% confidence interval, you have to mention that. This is the first element you have to mention. The second element, the true population parameter. So in this case, the population parameter we want to study is the percentage of accidents involving the teenagers. So this is your true population parameter. You have to mention that. So because that is the population parameter you want to estimate using the confidence interval. Okay, this is the second element you have to mention. The second component you need to mention is that falls inside of the interval. Okay? That means we are a certain level of confidence that the true population parameter falls into this constructed interval. Okay? This is how we explain or describe a confidence interval. 3 elements. So if you work on the homework questions, you will see many types of descriptions. So how do we know this description is correct or this one is not correct? You don't have to learn. You don't have to learn so many types of wrong descriptions. You just remember this template. Okay? If the description is different from a template, that's wrong. This is the only way we describe a confidence interval. Okay? 3 elements. Confidence level, you need to mention the true population parameter. The third one is fall into this constructed interval. Okay? Any questions on part B? The part C is explain what's 95% confidence mean. When we discussed the slides, we said we know that 95% of the sample will fall into this area. So when we study this 68, 95, 99.7 rule, we said that means 68% of the sample will fall into this area defined by 1 standard deviation. So similar concept here. 95% of random sample of size. This one is important. We have to define the sample size. So if we have different sample size, we will have a different interval. Okay? So for this particular confidence interval, that is for this sample size, we'll produce the true proportion that contains the proportion or confidence interval or sample proportion or the true proportion that contains what? So from here, we learn that we want to construct the interval, right? That's the interval we want to construct. That contains true proportion. Let me check. And that is how we explain what 95% or 90% or whatever percent confidence level is. And one thing we need to remember is we need to mention the sample size, because that confidence interval is particular for this sample size, given this 95%. and that means this interval will capture the true population parameter. In this case, we are talking about proportion. So any questions on part C? So part D, after we have the confidence interval, so how can we use it? And someone was using this information, and say in one of every 5 accidents, a teenager is behind the wheel. So the claim is that the claim is about the population parameter. So his claim is that this true population proportion is 1 of every 5 accidents involve the teenager drivers. So this is what he's talking about. He's talking about the population proportion. Is that okay? This is the population parameter. And we want to use our confidence interval to see if this is correct or not, or if likely or unlikely. So if we go back here, this is our confidence interval. So our interval is from 13.6% to 19.5%. This is our confidence interval. That means we're 95% confident that the true proportion will fall into this interval, which does not include 20%. 20% is somewhere here. So it's not in the confidence interval we constructed. So based on this result, we may have some conclusions. Does our confidence interval support his claim or not? No, right? Because it's not in this interval. So it must be either B or C. So the C is the figure quoted by that guy is outside of the interval. So that's how we construct a confidence interval for population proportion, and how we explain the meaning of confidence interval, and explain what the 95%, 90% confidence is. And also, after we have this interval, how do we use this to support some claim or be against some claim about the population proportion? Any questions? So this is one of our homework questions. Another type of question you may have is to calculate the sample size. So when you do a study, you don't know the entire population information, but you still need to design your survey and try to collect some sample. But the question is, what is the sample size we need? But before, when we calculate the standard error, we assume that we already know the sample size. But before we start our study, how do we know this p hat and q hat? We don't have any information. So how do we determine our sample size? So when we want to have our sample size, one thing we want to control is our margin of error. So we must have a value for the margin of error. Whether on 3%, 4%, or 5%. So that is your tolerance. That's your tolerance. So assume we know this, and these are the critical value. We also need to know. And in this case, if we want to calculate this, and n is a sample size, what value do we need, or do we assign for the p hat and q hat? In this case, we use the worst case scenario. We assume that the p hat is 0.5. The underlying logic is to make this one as large as possible, so that we can have a safe number of samples. So we have the safe number of samples here. So we know that the p hat plus q hat is equal to 1, and p hat and q hat, they are both positive. So what is how to maximize this p hat times q hat? So probably you already learned this. If we want to maximize this value given this relationship, the p hat has to be equal to the q hat is equal to 0.5. So that's the condition we can maximize, get the largest of this expression. So here, what you need to remember is that when you want to estimate the sample size without knowing any information about your sample, about your population, this is the number you use. And you need to use this number and plug it into this formula. And let's do one example. So a product manager wants to estimate the proportion of customers who are likely to purchase the new service within 3% with 95% confidence. So from the description, we know some of the information. For questions like this, we use this formula. Margin of error is equal to the critical value times the standard error. The information we know from the description is that we did 3%. This 3% is your target margin of error. This is the 3%. And your confidence level is 95%. And from the previous slide, we know that in this case, we use the worst case scenario, which means the p hat is equal to q hat is equal to 0.5. So our goal is to calculate the sample size n. Now we know the margin of error, we know the p hat, q hat. So how do we find the critical value? So how do we find the critical value? So based on which information do we find the critical value? The V star. So we mentioned the D star, the critical value is the number of standard errors or standard deviations. So that V star is defined by the confidence level. So if we draw a figure like this, we know we are talking about 95% confidence level. And this is our V star. So if you do not know the V star, always use this confidence level to find it. So if we visualize that, this we want to find the V star, the critical value that defines a 95% area. So this is a negative V star. So if you want to write it out, so this area is 95%. But still, let's use the step count, which I already did, because we know this guy follows a standard normal distribution. So we use the normal calculator in between. And here we are looking for 95%, suppose 95 there. And then we find our Z star. So this is 1.96, that's our .96. Now if we go back here, so if we go back to this formula, we have the Z star, we just found the critical value. We know the P hat, Q hat, we know the margin of error. The only unknown here is the sample size n. Then we plug the numbers in there, and then we can find the value of them. So this is another type of question we may have. So in this question, we want to have sample size. Any questions on this type of problem?
Can you work it out?
Okay. Let me work it out. So let me do the calculation. So let me plug numbers in there. So margin of error, that is 0.03 is equal to critical value 1.96 times the square root of P hat times Q hat. 0.5 times 0.5 equals to 1. So that's what we know. Let me let me put n to this area. Square root of n is equal to 1.96. Let me put 0.03 over here. 0.3 times square root of 0.5 times 0.5. So if I do more calculation, so this will be equal to 6.6 times 0.5. So the square root of this one is 0.5. So it's going to be 32.5 So you can verify the calculations. So this is the square root. Remember, this is the square root of n. And we have to square it. So the n is equal to 32.65 squared. So it's about 1066. So probably you can verify the calculation, but this is how we found it. Yes, sir.
Where do you get that 0.5 from?
0.5, because here we want to calculate the sample size, and we know nothing about our sample and population. And in that case, we use the worst case scenario. So in the worst case scenario, we assume that the p hat and the q hat are equal to 0.5. That's our assumption. Any other questions? Okay. I think that's all we have today, and we will continue our discussion next week.